Hello guys, welcome to Apex Tutorials. My name is Bino, and in this video we'll be going through question 7 from the November 2019 Mathematics Paper 1 Grade 12 past paper. Question 7.1, we have to determine f prime of x from first principle if it is given that f of x is equal to 4 minus 7x. So we are going to use the first principle. The formula for differentiating using the first principle is f prime of x is equals to the limit of f of x plus h minus f of x divided by h as h approaches 0. So the formula has f of x and f of x plus h. We are only given the f of x as 4 minus 7x, and it is up to us to determine the f of x plus h. So there was x, now there is x plus h. Where there was x, they substituted x plus h. So where there is this x, we will also substitute x plus h. So where there is x, we substitute x plus h. And this will be equal to 4 minus 7 into x plus h. So this negative, we will distribute it inside the parenthesis. So negative 7 multiplied by x will be equal to negative 7x. Negative 7 multiplied by h will be equal to negative 7h. So let me bring the h closer, negative 7h. So from here, we can go and substitute into our formula. So we have f prime of x is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. So we have determined f of x plus h as 4 minus 7x minus 7h minus the f of x, which we were given as 4 minus 7x. So in the place of the f of x, we substitute 4 minus 7x. Remember, we are dividing this by h as h approaches 0. So our f prime of x will be equals to the limit of 4 minus 7x minus 7h. From here, we distribute this negative inside the parenthesis. So negative multiplied by positive 4 will be equal to negative 4. Negative multiplied by negative 7x will be equal to positive 7x. Divided by h as our h approaches 0. F prime of x will be equals to the limit. So before, let's try to group the like terms. So we have 4 and that negative 4 as like terms, and we have a term which has an x here and another term which has an x there. And this h does not have any common factor. So we are going to group the 4 and that minus 4. And we also group the negative 7x and that positive 7x. And since the negative 7h does not have a common factor, we are just going to group that alone. And this will be divided by h as our h approaches 0. So f prime of x will be equals to the limit of 4 minus 4, which is equals to 0, negative 7 plus positive 7, negative 7x plus positive 7x will also be equals to 0, and we'll be left with negative 7h divided by h as our h approaches 0. So from here, we can see that that h and that h will cancel out each other, and we'll be left with f prime of x is equals to the limit of negative 7 as h approaches 0. So from here, we can see that we don't have a term which has h. So we are going to drop the limit and our f prime of x will be equals to -7. So we can't substitute this 0 because we don't have a term which has a h. Question 7.2, we have to determine dy over dx if y is equals to 4 multiplied by x to the power 8 plus the square root of x cubed. So we are going to differentiate this using the power rule and not the first principle. So we have y is equals to 4 multiplied by x to the power 8. So it will be much easier for us to differentiate the square root of x cubed if it is expressed as x to the power 3 over 2. So we know that if we had a to the power 7, this is just the same as a to the power 7 over 2. So we are going to differentiate x to the power 3 over 2 instead of differentiating it in the form of the square root of x cubed. So we have dy over dx. We are differentiating with respect to x, so we are going to focus at the exponent of x. So the exponent of x in this case is 8. We are going to multiply it with the coefficient of x to the power 8. So the coefficient of x to the power 8 is the 4. So 4 multiplied by 8 multiplied by x to the power 8. Since we are differentiating with respect to x, we are going to minus 1 from the exponent of x. Plus, we have 1 here. So this 3 over 2 multiplied by that 1 will be equal to 3 over 2 multiplied by x to the power 3 over 2. So since we are differentiating with respect to x, we are going to minus 1 from the exponent of x. So dy over dx will be equals to 4 multiplied by 8, which is equals to 32, multiplied by x to the power 8 minus 1. 8 minus 1 is equals to 7, plus 3 over 2 multiplied by x to the power 3 over 2 minus 1. 3 over 2 minus 1 is equals to 1 over 2. So our dy over dx will be equals to 32 multiplied by x raised to the power 7 plus 3 over 2 multiplied by x raised to the power 1 over 2. So if you wish to express the x raised to the power 1 over 2 as the square root of x, you are more than welcome. Question 7.3, we are given y is equals to ax squared plus a, and 7.3.1, we have to determine dy over dx. So 7.3.1 will be differentiating with respect to x, and 7.3.2 will be differentiating with respect to a. Let's do 7.1 first and differentiate this with respect to x. So since we are differentiating with respect to x, any function which is not attached to x will be treated as a constant. So this a is not attached to x, so it will be treated as a constant, and the derivative of a constant is equals to 0. So we already know that the dy over dx of this a is equals to 0. So let's determine the dy over dx of ax squared. So since we are differentiating with respect to x, we are looking at the exponent of x, and we are multiplying with the coefficient. In this case, the coefficient of x squared is equals to a. So the 2 multiplied by the a multiplied by x squared. And since we are differentiating with respect to x, we are going to minus the exponent of x. We minus 1 from the exponent of x. Our dy over dx will be equals to 2a multiplied by x to the power 2 minus 1. 2 minus 1 is equals to 1 plus 0. So question 7.3.2, we are looking for dy over dA. So since we are differentiating with respect to a, we are going to look at the exponent of a. So in this case, the exponent of a is equals to 1. So we are going to take that 1 and we are going to multiply it with the coefficient. So in this case, the coefficient of a is equals to the x squared. So we are going to multiply 1 by x squared. And since we are differentiating with respect to a, we are going to minus 1 from the exponent of a. This is plus, so let me rewrite our function. Y is equals to ax squared plus a. So the exponent of a is equals to 1. So we take that 1, we multiply it with the coefficient of a, which is 1. So 1 multiplied by 1 will be equals to 1. A to the power 1. Since we are differentiating with respect to a, we are going to minus 1 from the exponent of a. So our dy over dA will be equals to 1 multiplied by x squared will be equals to x squared. A to the power 1 minus 1. 1 minus 1 is equals to 0, and a to the power 0 will be equals to 1. That 1 multiplied by the x squared will be equals to x squared. So we have 1. A to the power 1 minus 1. 1 minus 1 is equals to 0, and a to the power 0 will be equals to 1. So any number or variable raised to the power 0 is equals to 1. So our dy over dA is equals to x squared plus 1. Question 7.4. The curve with equation y is equals to x plus 12 over x passes through the point A, which has an x coordinate of 2 and a y coordinate of b, which we are not given. Determine the equation of the line perpendicular to the tangent to the curve at A. So it will be very challenging for us to attempt to sketch this graph. But we don't have to sketch this graph in order for us to answer this question. So all that we have to understand is the concept of tangents. So suppose we have a theoretical function, let's call it g of x. And at this point, the tangent will be this line, let's call it L, line L. At this point, the g of x and the L share the same point, and they also share the same gradient. And they also share the same gradient. So if we can find the gradient of g of x at this point, we will have found the gradient of L. But we are not looking for the equation of this. We are looking for the equation of the line which will be perpendicular to L at this point. So by finding the gradient of g of x, we find the gradient of L. And we know that if functions are perpendicular to each other, so perpendicular functions, when you multiply their gradients, you will get -1. From here, we are going to differentiate the y. But before we can differentiate the y, let's express 12 over x as 12 multiplied by x to the power -1. So I hope you guys remember that if we have a over b, this will be equals to a multiplied by b to the power -1. Or if you had a over d to the power 3, this will be equals to a to the power d to the power -3. So it will be much simpler for us to differentiate 12 over x when it's expressed as 12 multiplied by x to the power -1. So we know that when we differentiate, when we find dy over dx, we are looking for the function of gradients. So the derivative of x will be equals to 1. The derivative of 12 multiplied by x to the power -1 will be equals to, we multiply this -1 from the exponent with that 12 from the coefficient. So we have 12 multiplied by -1 multiplied by x to the power -1 minus 1. dy over dx will be equals to 1. 12 multiplied by -1 will be equals to -12. X raised to the power -1 minus 1 will be equals to x to the power -2. So this function is our function of gradients. all the gradients of this function y are contained within this dy over dx. So if we want the gradient at this specific point 2 and b, we have to substitute this x value where there is x. So the gradient at a will be equals to 1 minus 12 into 2 raised to the power negative 2. So we have 1 minus 12 over 2 squared, which is equals to 4, and 1 minus 12 over 4 will be equals to negative 2. So our gradient at a is equals to negative 2. This is for the tangent and also for the tangent and the function y is equals to x plus 12 over y is equals to x plus 12 over x. So at the point a, which is 2 and b, these two functions, the tangent and y is equals to x plus 12 over x, share the gradient is equals to negative 2. So we are not looking for the gradient of the tangent or of this, we are looking for the gradient of the line perpendicular to the tangent. And we said that when they are perpendicular, the product of their gradient, straight lines when they are perpendicular, the product of their gradient will give us negative 1. So we use that formula, m1 multiplied by m2 will be equals to negative 1. So our m1 is equals to negative 2. So m2, which will stands for the gradient of the line which is perpendicular. So m2 will be equals to, so we divide both sides of this equation by negative 2. So our m2 will be equals to 1 over 2. So the formula for straight line is y is equals to mx plus c, or you can use that other one, y minus y1 is equals to m multiplied by x. You can use this formula or that formula. And another thing about this point a, which is 2 and b, it's a point where the perpendicular line, the tangent, and this curve intersect. So 2 and b also belong to the perpendicular line. So we have m is equals to 1 over 2. Is it negative or it's just positive 1 over 2? And a we were given as 2 and b. So y minus our y1 will be b. We are not given the value of b. And our m is equals to 1 over 2. X minus our x is equals to 2. So we take the b from the left to the right. It's going to change sign from negative b to positive b. And let's distribute the 1 over 2 inside the parenthesis. So we'll have 1 over 2x multiplied by negative 2 over 2 plus b. So y will be equals to 1 over 2x minus 1 plus b. We have to find the value of b. So we were given, originally the function that we were given was y is equals to x plus 12 over x. And we were told that it's passing through the point A, which has an x coordinate of 2 and a y coordinate of b. We substitute b where there is y, and we substitute 2 where there is x. Twelve divided by 2 will be equals to 6. So our b will be equals to 8. So in the place of the b, we substitute the 8, so plus 8. Minus 1 plus 8 will be equals to positive 7. If you have any questions, you can leave them in the comment section below. And if you find this video useful, consider subscribing, liking, and sharing this YouTube channel with your fellow mates.